We're looking at the domain and range of trigonometric functions. So let's recall about the word domain. So what is domain? Domain is to do with input values. So which, as and when it goes through the function, should give us a valid output. So when we talk about valid output, it should belong to real number. Okay. So basically, we are looking at set of values which are not to be of something like 1 by 0, infinite, square root of some negative number, so on and so forth. That's the funda. So this should not be the case. Okay, so valid input excludes the following scenarios basically. Okay, so it says no to the following. Now, the sine and cos and so on and so forth, all of this has the following domain and range. I'm not here to just give you guys the list. I'm here to explain the reasoning behind it. Okay, only then it will make sense. So we'll start off with the easy one. The domain and range of sine and cos are set of real numbers, that is all the input values will give us a valid output, and the range, but the output values are between -1 and 1. Okay, now let's look at the reasoning behind this. The reason behind this will be something like this. I can explain it with one of the logical things to do is to use right angle triangle and think about it. Now, so say I have an input of theta. Okay, so this is ABC and theta is at this corner. So we'll call this as say M, and this is N, and this is hypotenuse H. Now, sine theta is defined as what? So let me change the color. Sine theta is defined as opposite by hypotenuse. So this is nothing but basically M by H. Now, this is a fact. What is a fact? That any given side other than the hypotenuse will be less than or equal to the hypotenuse. Extreme case, it will be approximately equal to hypotenuse. If not, it's always lesser than. For example, M is always lesser than H. N is always lesser than H, right? Now I'll rewrite this. How is that I'm going to rewrite this? I'm going to divide both the ends with H. Okay. So basically I'm going to do this. M by H less than equal to H by H. These are nothing but your inequalities. You'll be learning this as one of the chapters. So this is basically 1, right? M by H I found it to be 1. So this is a fact. So from all of this, what can I infer? From all of this, I can tell that sine theta, which is equal to M by H, should also be less than equal to 1. Right? Because the very definition confines it to have such a value. And similarly, what can we tell about cos theta? Cos theta too is less than equal to 1. Okay, so it's a similar reasoning. Right, guys? So it's not too hard. It's a very simple thing because the hypotenuse, the denominator, is always greater than the numerator. So the ratio has to be less than 1. Extreme cases, it can be equal, and so we have equal to 1 as well. So this is shown here as well when we are going around the circle. Right, sine and cos value, you can see it is 0 to 1 and 0 to -1 as well. Right, you can see that. And here both are negative. And here you have positive and negative and so on and so forth. Right, guys? So all this is possible. Okay, so that's the reason. It's a very simple thing. Now, the difficult ones. So first and second is done. Tan. Right, let's start with the difficult ones. Okay, when it comes to tan, so let me first list the domain and range. So the domain is all the real numbers excluding 2n plus 1 pi by 2. What are the set of values such that n belongs to integers? What are the set of values 2n plus 1? Yes, these are odd numbers, is it not? These are odd numbers. So odd multiples of, not numbers, odd multiples of pi by 2. While your range is all the real numbers. Okay. Now, the reason. We need to understand the reason behind this. Why is it so? So we'll start off with the fact that tan theta is equal to sine theta by cos theta. Okay, we'll start off with the reasoning. See, remember, for a valid input, what kind of scenarios are we looking at? For a valid input, for input to be valid or for valid input, the scenarios which we can't include are, we cannot be having the following scenario. So we cannot have 1 by 0 as an scenario or an output. As an output, right? Agree? So when will this be 0, 1 by 0? That is basically, indirectly we're talking about, we cannot be looking at, this implies cos theta cannot be 0. Okay, so let's recall, when will cos theta be equal to 0? So cos theta is equal to 0 for what? For theta being equated to pi by 2, right? Then 3 pi by 2, including plus or minus, by the way. Then what? Yes, then 5 pi by 2, so on and so forth. So basically odd multiples of pi by 2. Let me show that to you guys. See, this is your pi by 2. So cos is 0 over there. This is your minus pi by 2. Then I came back to pi by 2 again. Now I'm completing the first 3/4 of the rotation. So this is 3 pi by 2. Here too it is 0. Then this is 5 pi by 2. Then this is 7 pi by 2. Right? Are you getting it? As and when I keep rotating, the number increases. The number of pi value increases, right? Are you getting why is this more than 2 pi? So as and when you rotate more, this value keeps on increasing. As simple as that. So for this reasoning, we can't have the denominator to be 0. And when is the denominator 0? For odd multiples of pi by 2. As simple as that. Got it? Now, the domain of cosec is all the real numbers other than n multiples of pi, where n belongs to z. Okay, and the next thing is the range. It is all the real numbers excluding values from 1 to 1. Remember, 1 and minus 1 are included. 1 and minus 1 are included. Okay. Okay. Now, all this is okay. The reason. Again, we are here to understand the reason. Why is it so? I mean, who or what is blocking us to have the other values over here as input? Well, it is from the fact that cosec theta is 1 by sine theta. Right? So same thing, same dialogue. For a valid input, for an input to be considered to be valid, we cannot have 1 by 0 as an output. This implies what? This implies sine theta cannot be 0. And now the recall aspect. So let's recall that sine theta is equal to 0 for which and all scenario? Theta is equal to, yes, 0 into pi plus or minus 1 into pi plus or minus 2 into pi plus or minus 3 into pi, so on and so forth. So for all the natural numbers of pi, right? So we have seen this. That's your 0 pi, 1 pi. You can see again sine is 0 over there. 2 pi, 3 pi, 4 pi, 5 pi, so on and so forth. Okay, right? So that would be your reasoning. Understood? Now we have sec value. So here too it's the same thing. So we have the domain and range to be the following. So domain turns out to be, domain is for sec, right? So we have all but this set of values such that n belongs to Z, and the range is, so sec will be all the real numbers other than -1 and 1. Okay, now so domain range, so the next thing is reason. Now why is it so, right? Why is this happening? The same thing, secant theta is 1 by cos theta. So I'll just copy this and paste. That's it, as simple as that. Or no, I have to copy this and paste actually. Right, cos theta cannot be 0. That's the whole funda over here is the denominator cannot be 0 and cos theta is 0 for this set of values, right? Actually this explains the domain but not the range. Now I didn't talk about the range over here and over here too, so I need to talk about range actually. When it comes to range, right, why is that we are excluding values from -1 to 1? So it's quite simple actually. So I don't have space over here, I'll try to kind of squeeze it. So range, see, we are always talking about 1 divided by a value which is between -1 to 1. So basically we're looking at 1 divided by a decimal value for most of the cases other than -1 and 1 decimal value, right? 1 divided by decimal value is what? Let's look at this. 1 divided by 0.2 is 5. 1 divided by 0.999, that also is more than 1. 1 divided by 0.001, obviously you get a very big value. So because the denominator is in is decimal for most of the cases, the range is, this implies, right, so this output is always greater than or equal to 1. Okay, of course its negative values also are taken care of. So other end it will be between -1 to infinity, and here it will be 1 to infinity. Okay, so basically the reasoning is because the denominator is always decimal, most of the cases it's decimal, right guys? Okay, hope that is quite clear. And here too is the same thing, right? Range is because of the decimal values at denominator. Now coming back to this, we are looking at domain as all the real numbers. Actually it's the same thing over here as well, right? No, sorry, not this, sign wala. Where is sign? Here, yeah. So it's similar to this. All I have to do is copy this, erase this and paste. Of course here the range is all the real numbers, right? And the reasoning is because of cot is, yes, cot of theta is cos of theta divided by sine of theta. And when can we have sine of theta not being equal to 0 for all of these values, right? And we are done, as simple as that. Okay, so this is the reasoning. See, everything is quite simple, everything is interconnected. If you understand one, everything is done, is it not? So let me recall, here we are looking at the domain and range of set of trigonometric ratios all the 6. And the domain aspect is that domains are a set of input values for which we get a valid output. So when we talk about valid output, we are excluding values like 1 by 0, infinite, square root of negative numbers. Now, when it comes to sine and cos, right? When it comes to sine and cos, the range is domain is quite simple. It's with all the real numbers. While the range has a constrained value, that is -1 to 1. The reasoning behind this is that sine is and cos is a value divided by a very big value. Because it is opposite by hypotenuse, hypotenuse in a right angle triangle is always bigger than the other two sides. For that reasoning, it's always between -1 and 1. Extreme cases, it is approximately equal to -1 and 1. Of course, we can't use this reasoning. You guys have to go back to this for complete understanding, right? So this is how you can remember is what I'm trying to teach, and yeah, also link the logic. Now, when it comes to tan, so tan is nothing but sine by cos, and cos theta value should not be equal to 0 for a valid input. And so theta is equal to 0 for this set of values. And so I can have any real number other than the odd multiples of pi by 2. And the tan turns out to have a range of r, and cot also turns out to be having a range of r, right? So you can interrelate them. So same kind of understanding goes for cosec, sec and cot also, right guys? The logic is very simple, the same pattern. We're just looking at the denominator and trying to exclude those values. Now you guys have to pause and think over and copy.